All right, let's take a quick look at the BOF problem from PWNABLE.KR. So all I've done so far is just downloaded the the binary and the source code. Typically when I get started on these guys, I personally like to just have a source, my script kind of first to talk to either the server or talk to my binary, just to get some sort of standard scripting kind of environment. So here we're going to connect to the server on port 4000 and then drop into an interactive kind of prompt that will just be able to send and receive to the server itself. So just a quick test of this will show. Okay, cool. So we do see output. That's nice. Again, let's go ahead and do some check sec. Get some idea here about what's going on. So we do have stack canaries, cool. NX if we did some exploitation on the stack. Might have to worry about that later. I don't think that's applicable for this problem. And then PIE. So if we were to get into some in-depth sort of analysis, we might want to turn off ASLR to make debugging a little bit easier, so that we have a standard base address. But we'll see if that's a problem here in a minute. Let's go ahead and check out some radar with the binary itself. I'm only doing this just because I don't really have IDA up and running right now, and I don't know, having some sort of terminal disassembler is kind of nice for me at least. So R2 BOF, radar doesn't by default do any sort of analysis, so we have to give it 3 A's to tell it to do to analyze all the things. If we didn't actually do the sort of analysis and try to print the function list with their command AFL, nothing would happen. So it's not until we actually do the analysis that we get our function list. So like IDA does this by default when you kind of load things. I think there's like a command flag you can do, R2 tac capital A, I think, to actually do this by default, but no big deal. So we see that we're currently at this 503 address. If we wanted to go to main, we could do like a seek to main and do some assembly here. If we wanted to print the disassembly, we could do like PDF. I guess all these radar commands kind of come naturally when you use it a bit. It's kind of like using Vim for a while. Like, you know, Vim at first is kind of annoying to get used to, but once you've done some of the commands, it's a little bit easier. Or once you kind of know the commands, it's a bit easier. Radar does have some pretty good usage though. So everything tries to be mnemonic. Like AFL is supposed to mean like analyze function list. But if you didn't know that, you could go through this list and append question marks to the end of each of your commandlets to get more verbose output about what commands are available. So like if we knew that A is analyze, we could do A question mark. Okay, cool. There's a function thing. So what can we do with functions? AFL, AF question mark. And then you can read through this to kind of see what else is available. There's a lot of commands you can do things with, lots of stuff. Once you get kind of familiar with it, it's a bit easier. But for us, AFL is, it's just kind of the default go with, default function list. The only other thing besides question mark is nice is that they've remapped pipe grep to tilde. So if you have like a large output, you could do like AFL tilde like main or whatnot. Or like in this case, if you wanted to get a quick glimpse about what kind of happens in a function, PDF gives you the disassembly of a function itself. You could also do stuff like PDF tilde call, so like grep out all your call commands, or like PDF, I don't know, ESP, give you all your commands that deal with ESP. So this kind of thing is kind of nice, just to have some sort of quick glimpse about what is kind of in a given function. But that's nice to do. If you don't want to do some sort of some list disassembly, you can do visual block with 2 capital V's. This will get you into like your typical control flow graph that's seen in IDA. There is your default view is kind of nice. I prefer to have this address list on your current address on the side with your opcodes, just so you can kind of just for reference, I guess, more than anything else. The other thing to note is that there is, for most of the functions, there's going to be this hotkey on the side here. So this gives you the ability to jump in and out of functions pretty easily. If you prepend any of these hotkeys with G, you'll go into that function. So if we just take a look at main real quick, you have your basic kind of function prologue, do some sort of stack stuff. We're bringing dead beef into ESP, which is then going to be passed, I guess, as argument 1 into the function itself. So it looks like this function is actually the meat of the binary. So we can kind of go into that real quick and see what's there. So again, just GA will maybe, there we go, jump us there. So in this function, if we want to get like your control flow graph high level view, like you have in IDA, you can do capital P to cycle backwards through various things. You can kind of get this sort of view. If it's a bigger function, maybe you want to see what the control flow graph kind of looks like at a high level. But it looks like this isn't really that complicated of a function, so we can just kind of go forward from there. So again, standard prolog, standard function prolog here, nothing special. Setting up some stack space to do things. Putting our stack cookie, I guess. Do we have it? Yeah, so our stack check. At the end, if we wanted to do some sort of really kind of start doing some larger analysis on this, you can start renaming variables like you would in IDA. When you're in this view in particular, if you type colon, you'll get into your kind of default command line radar view. So you have your question mark and everything else here. The command to do your variable renapping, or renaming rather, is going to be AFVN, so analyze function variable name, I guess. And then here you can type complete things. So like if we see that this local ch is our stat canary, do like local ch and then like whatever stack check stat canary, and then we have like our stuff here that we can use. So that's kind of nice. But moving forward, so we move this overflow me string into ESP, call puts. Okay, so I guess we're just printing out this overflow me string, getting local to ch and EAX. Okay, so just moving that value into EAX and then moving that value to the first parameter of gets. Okay, so we're doing a gets on this parameter, and I guess just having done these a bit, anytime you see a call to gets, it's typically going to be or I don't know, at least what I've seen, typically going to be some sort of exploitable condition because there's no bounds checking on it. So we can overflow this local stack variable, past the stack a bit. But canaries are on, so if we wanted to do some sort of exploitation of it, it might be a little difficult because that stack canary is going to be in the way of our overflow. So that's just something to note there. So we do a gets, and then we compare EBP plus 8. So anytime when you add to your EBP in 32-bit at least, that's typically where your pass-in arguments are going to be. So I believe 8 is our first argument. So it looks like we're checking that dead beef that we passed in got changed to Cafe Babe. At least, or that's what this condition is checking. So this should fail always unless we could we could change something for it. Just so we kind of know what's going on. Also in this view, your Vim bindings for moving around work. So your HJKL moves you around, or your arrow keys work just the same. So it looks like we have this NA string that gets puts, passed to puts. Okay, so that's one thing. And then over here we have our binsh string being passed to system. Okay, cool. So it looks like if we pass this comparison check, then we will just be handed a shell, which is kind of nice. The rest of this function just looks like standard epilogue stuff. So we do our check for the stack to make sure that the canary is still intact, and then kind of return from there. Okay, so that's nothing too ridiculous here. So I think the main point of this binary is just to change that dead beef that was passed in to Cafe Babe. And the way that we can do this is via gets. So because gets doesn't do that bounds check, we can overflow this local variable past the stack boundary into the parameter that was passed in, and overflow that with Cafe Babe. Now I think there's a couple ways we could do this. So like your standard CTF way, if we were racing or some point, would be to not really care where exactly that offset is and just throw a bunch of Cafe Babes, like whatever, 100 Cafe Babes, and have it work that way and see if it works. I guess we could try that real quick and see if it actually works the way we expect it to. So like shepherd equal, I don't know. I actually don't know where this is. I guess it should be hex 48 maybe plus something. I don't know. Let's do like that many ish. I don't know. We'll do like it's like 40 for now. and then we'll just send that to the stuff. And so instead of doing the remote binary, we'll do a local kind of process here. So if our theory works, then this should just hand us a shell. So we're just going to send a bunch of these to the thing, the process, and then go interactive on it. Quick check here. Okay, cool. So that's one way of doing it. So again, our buffer just our stack buffer was overflown via that gets command and overflowed this parameter that was passed in. Now maybe that's one way of doing it. CTFs kind of do that for sure, but maybe we wanted to be a little bit more surgical, a little bit more kind of precise about how we could do this in a more difficult problem. So maybe we only cared about replacing just the bytes that control Cafe Babe and not just the whole payload. So let's kind of go through that process, I guess. In this case, we'll use GDB. So Binjitsu comes with a nice ability to attach GDB via scripts. And so what we'll do is, because we know that there's this gets call, we'll have the process run until it's receiving input and then attach to it. And then at that point, we will be attaching just after we send input. We will be given a GDB attachment, which will be super nice. By default, if we do this, Binjitsu will split our tmux pane horizontally. So we get this sort of output where we have kind of GDB on the bottom and our script on top. I'm not a fan of this just because we have screen real estate kind of above us. I would kind of prefer to have this this vertically. So what we can do here is do something like this, where we can tell GDB, hey, thanks for the defaults, but I would prefer to have this other thing. So we can set the terminal to do a tmux and to split horizontally this way. That way, when we do our attachment, we have this vertical split type thing. Okay, so we've split GDB, or we've attached with GDB to the binary. We're now attached somewhere after that gets call. So if we next a bit, we see that we're in this read. One thing we can do to get kind of out of this read, out of this gets, back to our main function, it looks like, which looks like to be at like stack frame 5 or something. We could just finish to kind of return and traverse our stack frames back a bit until we get to our main function, where we see our EBP plus 8 here. So what we want to do, if we want to be surgical about this, is we want to be able to throw some sort of payload and be able to identify where in that payload are we checking for this Cafe Babe. And luckily, there is a nifty little command in Binjitsu that allows us to do this, called cyclic. So cyclic will give us a, there's a name for this, I don't know what the name is, but it's some sort of, it's a pattern string that when checked, we could give it some sort of substring, and it can tell us, because it knows the default format of the string, kind of where that substring is in our main string. So like maybe if we were to throw like this cyclic 100 string at this binary, we could check what EBP plus 8 is. That's just for an example, say that EBP plus 8 is HAAAA. We could then use this cyclic find guy to tell us that at HAAA is actually 28 bytes into this string. So what we could do is pad 28 bytes and then put whatever number we would want into this comparison, like in our case, Cafe Babe, and it should surgically be inserted into the payload where we need it to be. So let's take a quick look about how we could do that, practically. So wait for this to give us back control. Thank you. Cool. Okay, so instead of our 40 Cafe Babes here, let's take shellcode and send something like cyclic 200 and just kind of see what happens with this. Cool, so we're back here. Again, we'll finish down to go back to here. And then at this point, there's a couple of ways we can kind of look at what's in this memory address. So there's a hex dump function that gives us the ability to do, like it says, a hex dump of this EBP plus 8 address, which will give us kind of the byte for byte output as well as the ASCII representation of that. So in this case, we can see that at EBP plus 8, NAAA is the substring that's at that memory location. If we're familiar with WinBag, maybe, there's most of the WinBag command, or most of the general WinBag commands are in pwnbag as well. So you could do something like dd EBP plus 8 to see that value, you know, your DBs, et cetera, et cetera. But in our case, we kind of care about this substring. So NAA is actually where we'll be. So what we can do is, there's two things we can do at this point as well. So some people actually like to know what that offset actually is, just for completeness, I guess. So cyclic find NAA will give us 52. So like in our function, or in our script, we could replace this cyclic with a cyclic find, or sorry, not cyclic find, with just a padded number of A's for 52, and then we could put our value after that. Me personally, I don't really care that this is actually 52. I just care that cyclic find returns the number that we need, and we can just kind of keep this function in the binary itself. Sometimes in more complex payloads, more complex exploits, we do really need to know this exact number where this is necessary, but for these small ones, it's not really that big of a deal. The other thing that's nice is we can't just drop in like a number here, right? Because we're handing a number to a string, and because of NDNS and x86, we kind of need this to be packed some way. So one thing that people will do is this struct packing, where you'll import struct, do like struct.pack. Oh geez, I think it's this. Is that what it is? No, it's the other way. This way. Okay, yeah. So this is kind of what we can do normally to pack this number into the string that would be necessary to get the right NDNS for the problem. Luckily, Binjitsu comes with just shortcuts to do this. So P32 is just a function that allows us to do this sort of thing automatically. So P32, I think, literally is, okay, it's wrapped somewhere else, but that's fine. I think P32 is actually just this struct pack command with just this replaced, but no big deal. So what we can do here is just, instead of doing this cafe babe, we will drop in our cafe babe packed value, and if all goes well, this should actually be the surgical control of that value, of that parameter to be cafe babe. So let's go ahead and check that. So we should have all that fanciness. Go ahead and do our guy here. So again, move forward a bit, finish a couple times to get back through the stack frames, and then we can do a check. Well, actually, we can see it here, cafe babe, and we can also check with dd EBP plus 8 to see that we do have cafe babe. And if we go just a bit further to kind of further ingrain in us that what we've done is right, we can see that at the call of system we do get our binsh. So cool. So we should be able to continue and see that we do execute our shell. And then for fullness, we'll just need to remove this attachment and just throw the payload at our local process and be handed a shell here. Fantastic. So that's step one. Hopefully this doesn't have to be changing anything on the remote side. So if we throw this to the remote binary, again, just changing from our local process to remote, we get a shell. Fantastic. And our flag is here. I'll let it be an exercise to the viewer to kind of do this process and print the flag out themselves. But that is essentially kind of my workflow through BOF. Thanks much.